Hello. Today I'll be explaining Newton's three laws of motion. Most people think of physics as just math or an idea, but physics is acting on everything all the time. As you are sitting or standing right now, there are forces acting on you. Sir Isaac Newton lived way back in the 17th and 18th centuries and was very influential to how we view physics today. His first law states an object in motion will stay in motion until acted on by an outside force. A good example of this is a baseball being stopped by a glove. When the baseball is thrown, it travels in the direction that it is thrown, only slightly slowing down due to air resistance and gravity. But as soon as it hits the leather padding of the glove, its motion is ended because it was acted on by an outside force. Another way this law is said is an object at rest will stay at rest until acted on by an outside force. A good example of this is a baseball being hit off a tee. When the baseball is on the tee, it is completely motionless, meaning at rest. But when it is hit by the bat, it is put in motion and no longer at rest because of the force acted on it by the baseball bat. Newton's second law is force equals mass times acceleration. This law might be a little more difficult to grasp at first, but consider this. Which do you think takes more force to lift? This stick or this 8-pound weight? Exactly, the weight. Now, which do you think will accelerate faster? A ball that I hit with not much force or a ball that I hit with a lot of force? Exactly, the ball that I hit with a lot of force. Now that we know how close the relationship is between mass and force, as well as acceleration and force, we can understand that force equals mass times acceleration. Now for our last law, Newton's third law of motion. Newton's third law states, for every action there is an equal and opposite reaction. Breaking this down, the action that this law speaks of is the force transferred from object A to object B. Equal means equal in magnitude of force, and opposite means opposite in direction. This law can be demonstrated by bunting a baseball. When the ball is pitched, it is given a force which is transferred to the baseball bat. Here, the ball is acting as object A, and the bat is acting as object B. When the force is transferred to the bat, it is equally distributed and no force is lost. The ball goes the opposite direction, but you might be wondering why the ball doesn't go as fast as the pitch. This is because some of the force is absorbed by the bat, and the bat vibrates in the batter's hands. Thank you for watching.